Okay, Pablo, so this one is going to be the same deal for number 9. I see that you got 16 on there, but I don't see 16, question 16 anywhere, so I don't know about, I can't answer that one for you. But I'll do this one, and I'll do number 8 because it's different. It's the area. So this one, to measure the height of the tree, she has her little brother stand so that the tip of his shadow coincides with the tip of the tree's shadow at a point C. So her brother is 1.2 meters tall, and he's standing 4.2 meters from Cynthia and 6.5 meters from the base of the tree. Okay, so what happens is if we draw that out as two separate triangles, here's the big one with the tree, for T for tree, and then we should have a right angle for the tree growing straight up. And this side, this is the tricky part, this side is 10.7 meters altogether. So that triangle looks like that. And then the triangle that her brother makes is smaller. It's 4.2 meters, and he's 1.2 meters tall. So the first thing you need to do is you need to label these triangles. I think they started you off TEC, and this one's BRC. And you first have to show that these two triangles are similar. So you're going to do your angle TEC equals angle BRC, and that's given because they're both right angles and so on. You're going to get angle similarity when you're done. Once you've proven that, again, it's just a really simple ratio. All you have to do is, what do they want? The height of the tree, right? So we'll call that x. So we're going to say x compared to 1.2 on the other triangle has to be the same as 10.7 compared to 4.2. And if we do the Z pattern like that, we'll get x equals these guys multiplied together divided by this guy, whatever that happens to be. Okay, we'll try and fit 2 videos on one here so that we can finish off. With the area, what happens is there's a little bit of a different relationship, all right? So the nice part about these questions is that they start off telling you that these triangles are similar, so you don't have to do the proof of the similarity to begin with. And the relationship here that's really, really important is that the ratio of the sides is one thing. So we can see by the sides that they gave us, for instance, here, like 9 and 12, that the ratio of the little triangle to the big triangle is 9 to 12. In lowest terms, I guess we could put that down to 3 to 4, right? So that's for the sides. And what that tells you is that the ratio of the areas is the square of that. Because when you do area, you're multiplying 2 dimensions, right? So if each one of them is that same ratio, then you have to multiply by that ratio twice. And that's a squared value. So ratio of the areas is going to be 3 squared over 4 squared, which is 9 over 16. So if we know that the smaller area, the area of the smaller triangle, I'll use ST for small triangle. No, let's do it. Let's do it right. Area of I can't even read those letters, Pablo. UST maybe? UST. That's this triangle. I'm trying to take the vertices. U, S, and T, I think it says. Is equal to 72, then the area of triangle PQR is going to be, well, here's how we'll find it. We'll say 9 to 16 equals 72 to x. And we'll do the Z pattern again. So the area of PQR is 16 times 72 divided by 9. I hope I'm still making sense because I know I'm getting tired. It's 10 o'clock and it's been a long day, but I hope that helps. And this would be centimeters squared. Each one of these, for number 8, you're going to do exactly the same way, all right? So I hope that helps, and if not, maybe we can get together on the weekend and help you out a bit with this, because it looks like you're just starting into the similar triangles and trigonometry unit. Have a good night.